to go over a little bit of the background, the science of carnitine. It's very interesting. I think hopefully you'll find it interesting as well in terms of its function in fat metabolism and energy metabolism. Basically, it's positioned for optimum fat-burning support throughout the day. And our bodies cannot burn one molecule of fat without carnitine. It's really a key metabolic precursor to doing that. So in terms of, when we talk about fat burning or fat metabolism, and a lot of focus on fat-burning products are focused on caffeine and those stimulant-type products. Those primarily release fat from fat cells. If we want to use fat as an energy source, and a lot of the research with carnitine in terms of understanding its metabolism actually started out in the exercise world in terms of athletes using fat or trying to stimulate the body to use fat as a fuel. And I'm sure many of you know that free fatty acids or fats are a primary fuel in athletes, especially endurance athletes, so endurance cyclists, marathon runners, things like that. The body, in its wisdom, tends to use concentrated energy for long-term exercise and to promote the use of fat. So using, let's say, the caffeine and the other stimulants, that functions primarily to release fat from fat cells. So it'll kind of release or mobilize fat. And then the next step, as that free fatty acids is found in the bloodstream, gets into the muscle or delivered from the muscle, we want to deliver those free fatty acids into the mitochondria, which are actually the powerhouse organelles of the cell, to generate ATP, and lots of ATP under aerobic or metabolism with oxygen. That's where carnitine plays a role. So basically, I kind of look at this as two steps: release and burn. The caffeine and these other stimulants release fat from fat cells, a process called lipolysis. And there's actually a hormone called hormone-sensitive lipase that is stimulated by caffeine or epinephrine. Actually, caffeine stimulates the adrenals to produce epinephrine. That epinephrine stimulates hormone-sensitive lipase to break down fats from fat cells, liberates free fatty acids. The next step is burning, which is called beta-oxidation, and that's where carnitine plays its primary role. It will actually, what's called a carnitine shuttle, shuttle in fats and also coenzyme A into the mitochondria to burn the fat. So we cannot burn any fat without carnitine.